about different types of softwares, and we have discussed about different types of softwares. What is software? What are the main mottos to develop a software? Whenever we are developing a software, what are the things we should keep in mind? So we have discussed all these things. Okay. So now, as of now, we will start discussing about software life cycle. Okay. Software life cycle. So we discussed some basic issues in software engineering in the previous class. So we also examined the key differences between the exploratory program development style and the where the programmer has complete flexibility regarding the activities he performs to develop the software and the software engineering approach. So we highlighted that in contrast to the exploratory style, the modern software development approach emphasizes adherence to a well-defined software lifecycle. Okay, so in simple words, we can say that a software lifecycle model is a lifecycle model prescribes the different activities that need to be carried out to develop a software product and the sequencing of these activities. Okay, so basically, software lifecycle or software process is a software process where it is defined by a series of identifiable stages that a software product undergoes during its lifetime. Okay, so the software lifecycle is also sometimes referred to as the system development life cycle, that is SDLC. Okay, so here we will discuss some important issues associated with the software life cycle. Subsequently, we shall also discuss the classical water life cycle model as the basic life cycle model. So we will be discussing about classical life cycle model, and then finally we shall examine a few well-known life cycle models. Okay, so every software product starts with a request from the product for the product by the customer. Okay, we know that customer always demands something, and based on the demands or requirements of the customer, we actually develop a software. So this is called product conception. Okay, so starting with this stage, it undergoes transformations to a series of identifiable stages until it is fully developed and released to the customer. Okay, so after release, the product is used by the customer and is finally retired when it is no longer used. So this forms the essence of the life cycle of every software product. Based on this, we can define software life cycle as follows. So this is the life cycle model. That is, first we actually there is a feasibility study, and then requirement analysis and specification, then design, then coding, then testing, and then maintenance. We will be discussing about all these requirements one by one, but as of now that it is the actually the order should be like this. Okay, so life cycle is not peculiar to software development. Okay, so in fact, almost every business organization carries out its business through some sequence of well-defined steps. Okay, these are nothing but the steps which you need to follow while developing a software. First step, after first step, only second step will come. You cannot uh, mismatch all these phases. Like first you need to do feasibility study, and then only you can do the requirement analysis. After feasibility study, you cannot directly jump to design or coding. In this way, it cannot be done. Okay. So see here, manufacturing industries also follow certain steps to develop their products. The software life cycle can be considered as the business process for software development, and therefore a software life cycle is often referred to as a software process. That's why it is called a software process. Though throughout we shall use the term software process and software life cycle model interchangeably. So, however, many authors or in many books, you may find that software lifecycle model form a process model based on on some consideration. Okay, so in contrast to a software lifecycle model, a process model describes the lifecycle activities in more detailed and precise terms, often by using mathematical notation. So we will be using some mathematical notations to denote it. So we will be doing those things in our next classes. So example, if you can consider as for example, the activities carried out and the documents produced after different activities are being used as mathematical notations. So here we will be discussing about the different stages in a software life cycle. So traditionally, after product conception, the first stage in the software life cycle of any software product is usually the feasibility study. Okay, this is the first one. So the subsequent stages actually are requirement analysis and specification. Next, like design and then coding and then testing and maintenance. So each of these stages is called a life cycle phase. So this is called a life cycle phase. During each life cycle phase, usually several types of activities need to be carried out and several documents produced before the end of the phase. Okay. So while doing these are not only terms. In these terms, you need to do a lot of activities while developing a software. Students, are you following? Are you there, students?
Yes, madam.
Okay. Yes, so
मैम थोड़ा स्लो पढ़ाते
हेलो हाँ बोलो
बोला मैम थोड़ा स्पीड स्लो करते ना थोड़ा ज्यादा स्पीड
अच्छा
है
ओके 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 ज्यादा स्पीड हो जा रहा है ओके ओके So basically, what is a life cycle model? A life cycle model graphically represents the different phases of a cycle, of a life cycle. Okay. So whenever you are having, I will be giving you how it is graphically represented. So basically, it is just as of now understand whatever software life cycle you are using in those life cycle, all these features should be common. Okay, but there will be some additional features also. Also, some features will be more advanced, but these features are the basic of any software lifecycle model. So basically, a software lifecycle model is a descriptive and diagrammatic representation of the software lifecycle. So basically, a software model maps the different activities that can be performed on a software product from its inception to retirement into a set of life cycle phases. So different life cycle models may map the basic development activities to phases in different ways. So thus, no matter which life cycle model is followed, the basic activities are included in all life cycle models. Okay, so these are the basic activities that are included in all life cycle models. Though the activities may be carried out in different order in different life cycle models, organization may use the basic software process to meet their specific models. Okay, so their process model may also be recommended using specific methodologies for carrying out certain activities. Like though the term process and methodology are at the same time, but can be used interchangeably and the difference can be understood very easily. So a process covers all the activities starting from product inception through delivery and return. So it addresses issues such as ordering of the activities like reuse, it's like documentation, testing, parallel work carried out by team members and coordination with the customer. So in contrast, a methodology covers only a single or at best a few individual activities that were involved in the development. So example testing methodology, we will be learning testing in the fourth module, design methodology in the third module, or in the second module, we will be learning about design methodology and addresses a single activity in a life cycle. So that's why it is why life cycle model is used. So basically, like as I said, a software life cycle model or it is a process model which gives us a descriptive and diagrammatic model of software life cycle. So it basically identifies all the requirements all the activities required for product development. So it establishes a precedence ordering among the different activities, and also it divides life cycle into phases. So and also several different activities may be carried out in each life cycle phase. So as I said, for example, the design stage must consist of, we will be learning design as I said in the second module. So the design stage might consist of structured analysis activity followed by structured design activity. Okay. So why do we model a software? Okay. So a written description forms, actually it is a written description. So it is forming a common understanding of activities among the software developers, and also it helps in identifying inconsistencies, redundancies, and omissions in the development process. So it also helps in tailoring a process model for specific projects. Okay. So also processes are tailored for special projects like a documented process model. It actually helps to identify where the tailing is to. So see here, the development team must identify a suitable lifecycle model before doing any further process. Okay. So whenever a client comes to your company and says that I want a software and that software should have this much of specifications, so what you need to do is first you need to model that specifications in a diagram, in a that is all the requirements in a chart. Okay, and then you need to draw a design via a life cycle model, which is a diagrammatic, and that diagrammatic view should be either first shown to the client, but client will not understand that thing. For that, what you need to do is you need to develop a prototype for that. So there are different types of models. We will be discussing each and every model and why one model is better than the other one. We will be discussing. So basically, the primary advantage of adhering to a life cycle model is it helps development of software in a systematic and disciplined manner. Okay. So when a program is developed by a single programmer, that programmer has the freedom to decide his exact steps. Okay. But remember, whenever the programmer is developing that model, he should keep some certain points in his mind. Like whenever whatever software that he has to design, that should match the requirements, and also what the model should not have any difficulty to be understood or to do the next exact requirement. Okay. So see here, when a software product is being developed by a team, there must be a precise understanding among the team members, as I said, as to when to do what. Like team members will decide that when module they actually each software can be divided into different modules. Okay. So actually so each software, students, are you following? Whenever you are designing a software, all the software can be divided into different modules. Okay, module one, like this one is module one, this one is module two, this one is module three, and this one is module. So these are the different modules that a software will have. Okay, now see, whenever suppose you are giving this module one. Module one is consisting of the only first login and registration module. Okay, it is module one is nothing but the login module. And first, whenever you are entering into a site, okay, so in that site, like as you have seen that there is, I have opened a browser. In the browser, I have opened Gate 2022. Okay, so whenever I want to view the site Gate 2022, first it will ask me that whether you are a new user or an existing user. Okay, so if I'm a new user, what it will do first, it will tell me that you need to give your basic details and need to generate your user ID and password. And that user ID and password should be kept for future reference, okay, as a future reference for next time login. So that is the that is the module login and registration. So suppose team one is doing that module, okay. Next team two is doing some other implementation like more whenever after registration and login, what functionality is going to be added in the software, that is done by the team 2. Another team 3 is doing some other module and team 4 is doing some other module. Okay. So what it basically says that team 3 team members should know when to do what. That is, this is the flow of the software. That is, first module 1 will be done and then module 2, that is if even if they all the team members are doing it concurrently, but whenever it is delivered to the user, first the module 1 activities that will be performed, and then the module 2 activities will be performed, then 3, then 4. In this way the flow will be there, okay. But whenever you if it happens that without doing module and module 2, module 3 is executing, then that is not a correct software design. So that's why all the team members should know that when to do what and after which module should come. So in this way it should be done, okay. So otherwise it would lead to chaos and project failure. So as I said that whenever if you are doing module 3 before module 1 and module 2, then it will lead to chaos and project failure, because whenever you are logging into that website gate 2022, if you are direct if you are after logging if after visiting that website, if you are directly rechecking to payment option, then that would create a chaos, because you have not even registered in that site, or also you have not given your basic details, educational details, and then all the basic details you have not given. So that's why it would lead to chaos and project failure. So that would say that we have done a failure project. So that should not be done in that case. Okay. Then are you there? Are you following?
Yes,
This
ma'am.
subject is this subject is a theoretical subject. So don't sleep. Okay, wake up. I would walk you after every 10 minutes. Okay. So see here. So a software project will never fail if one engineer starts writing code. Okay. Another concentrates on writing the test document first, and yet another engineer first defines the file structure, and another defines the input output for this portion first. So in this way, if the thing is done, that's why we have designed this and this flow process flow. Okay, we need to so another defines the input output for its portion first. Next, a life cycle model defines entry and exit criteria for every phase. So whenever we are using any entry or exit, whenever we are using any life cycle model, there should be an entry phase as well as exit phase. So that is defined by the life cycle model. Okay, and also phase is considered to be complete only when all its exit criteria are satisfied. Okay. So next is the phase exit criteria for the software requirement specification phase. So for that, we will be using software requirement specification, that is also called SRS document, which is complete, reviewed, and approved by the customer. So as I said, whenever the customer is demanding some requirements, that you need to make a chart of it, and that chart, and actually it is not a chart, it is called software requirement specification document. But as of now, as you are new to this subject, that's why I'm saying it as a chart. It is a non-technical term, but here that chart should be made, and after that chart you should uh, complete the chart, and that complete chart should be shown to the or reviewed to the customer, and if the customer approves that chart, then only designing should start. Okay. And in the designing, first you need to make a design of that software life cycle of that software by drawing a diagram, okay, diagrammatic view. So a phase can start only if its phase entry criteria has been satisfied. So if only the first phase is phase criteria has been satisfied, then only a phase can start. That is, we know that in the first phase, the requirement analysis and specification is there for every life cycle model. Now, suppose if you are developing a software and you do not have that particular requirements, then that phase criteria is not satisfied, and you cannot say that I can develop that particular software, but I do not have that requirement. So that is not acceptable. Only you can develop a particular software if you are having the requirement. Okay, so that's why if the condition is not satisfied, then it will not start. Okay, so it becomes easier for software project managers to monitor the progress of the project. So that's why if you do it sequentially, then the software project for the software project managers, it becomes easier to implement the life cycle model. So when a life cycle model is adhered, the project manager can at any time fairly accurately tell at which stage, example design, code test, etc. of the project is. Otherwise, it becomes very difficult to track the project progress of the project. Okay. So the project manager would have to depend on the basis of the team members. So basically, a life cycle model forms a common understanding of the activities among the software engineers and helps develop software in a systematic and disciplined manner. So software development organizations normally prepare an accurate documentation of the life cycle model they are following and require all their software developers to master the same. So good software development organizations normally document all the information regarding the outputs to be produced at the end of different phases. So methodologies to be adopted. So in software development organizations actually expect the fresher engineers recruited to the organization to fast master the organization software development model. Okay, that means as we have seen a proverb that you cannot fill an empty, you cannot fill this. Suppose this is a cup. Okay, you cannot fill a full cup. Okay, even if the cup is partially filled, also you cannot pour. Uh, Also, you cannot pour tea into that. You can only fill tea into an empty cup. Why? Because that cup is empty. It is having nothing in there. So if you keep on pouring, everything will be there. But if you are pouring tea into a cup which is half filled or fully filled, then that is not a correct, because your uh, tea will get mixed with the already present tea, and it will make a haphazard thing. So that's why companies always recruit freshers, because freshers are actually empty cup. They do not have anything in their mind. However, the company will train them. They will do according to the training of that company. So that's why they require fresher persons, so that whatever the company will taught them, whatever the company will train them, they will understand that, and they will do according to that company rules and according to their requirements. They will not apply their brain and will not do anything which is harmful to that company. Suppose suppose there is a person B, okay, and there is a person A, and A is having no knowledge, okay, and B is having little knowledge. And in a also there is a proverb in Bengali that we say that Alpo Vidya Bhayankari. Why it is said? Because he already partially knows something. And if the company is letting him know, and if the company is training him, then B will cross verify that I know something about this logic. Suppose the company is training PHP, okay? So B will tell that I know PHP, and the way you are making us learn and you are training us is not the way it should be, because I have little knowledge. Whereas A will say that I do not have no idea about it. So whatever you will be teaching me, that is correct. Okay, Satyavachan. They will think it as Satyavachan, whereas we will cross verify it because he will have doubt as he has some prior knowledge. So that's why companies prefer recruiting fresher people. Okay, so that is a good news for all of you because you all of you are fresher, and if you get job in a company, so remember this point that don't get less confident because you are freshers and you are empty cups. So whenever you will go to a company while giving exam, so you should remember that you are an empty cup. Whatever they will tell you, they can mold you according to their requirements. Okay, actual word is mold. So they can mold you according to your requirements. So students, are you there? Are you following?
Yes, ma'am.
Actually, this leads to a problem known as 99% complete stream. Since life cycle models have been proposed, we will confine our attention to a few important and commonly used models. So these are the different life cycle models which we will be discussing in this chapter. First one is classical waterfall model. Okay? Next one is iterative waterfall model. Third one is evolutionary model. Fourth one is prototyping model. And the fifth one is spiral model. So these are the different types of waterfall life cycle models. Basically, what is software engineering? Software engineering is a systematic collection of decades of programming experience together with the innovations made by researchers. Okay. So basically, a fundamental necessity while developing any large software product, adoption of a life cycle is necessary. So these are the summary of this engineering and models. So adherence to a software lifecycle model, actually it helps to do various development activities in a systematic and disciplined manner. Also, it makes easier to manage software development. So that's why a good life cycle model, besides clearly identify the different phases in the life cycle of a software product, should unambiguously define the entry and exit criteria for each phase. So a phase can start only when the corresponding phase entry criteria are satisfied. Similarly, a phase can be considered to be complete only when the corresponding exit criteria are satisfied. As an example, the phase exit criteria for the software requirement specification phase can be that the software requirement specification document is ready, has been reviewed internally, and then has been reviewed and approved by the customer, as I said. So only when these criteria are satisfied, the next phase can start. So this is the summary of all the things which I have taught in this class and the previous class. So in the next class, we will be learning about this life cycle models, that is classical life cycle waterfall model. And this is the diagrammatic view. So we are having our next class when, students? Next class? We are having our next class tomorrow. No, not tomorrow. Yes, tomorrow. Tomorrow from 1 to 2, we are actually 1 to 1:50. We are having our next class, right? So in we are having lab, so we will continue this concept. That is, we will start life cycle model. So we need to complete the module 1 first, and then we will be doing some discussions on lab. Yes, Shuman, you want to say something?
No, madam.
Anyone having any doubt? Anyone having any doubt? अच्छा, जिसको फास्ट फास्ट लग रहा था उसको अभी ठीक लगा क्या? मेरा स्पीड अब सही है? Students, the one who said that I am teaching fast, is it okay for him? I need a feedback, otherwise how can I understand that you are comfortable with my teaching style or not? Is it okay, students? Respond, students.
Yes, madam.
Okay, fine. So So time is also over, students. So thank you, students, for attending today's class. We will have our next class tomorrow from 1 p.m. So again, we will meet in our next class and we will do some more concepts of software engineering. So thank you, students. Now you can
Thank
leave.
you, ma'am.
Thank you, ma'am.
Thank you, madam.
Thank you.